Hey everybody, my name is Richard Nugent. I am an economist and the lead developer of HEC-FDA for the Hydrologic Engineering Center. In this video, we're going to talk about rating curves and how to define your rating curve in HEC-FDA version 2.0. Recall that the rating curve represents the relationship between stage and flow. You can see that relationship in the upper left-hand side. This relationship is very important and is required if you are using an exceedance probability function as defined with flow. All right, so if we're going to use a flow frequency function, we need a rating curve so that we can relate the flow to a stage and we'll then take that stage and relate it to a dollar damage value. So in the upper left-hand side, we see that rating curve, the stage flow curve. And what we're going to do is define in HEC-FDA version 2.0 the distribution of stages that we expect for a given flow. So let's define this relationship in HEC-FDA version 2.0. Okay, so we'll take a look at the user interface, and we're going to find rating curves within the study tree under stage transforms. I right-click, and I'm going to create a new rating curve. We should give the rating curve a useful name, something like impact area 1 without project for analysis year 2023. All right, so we know we know what this rating curve represents. And we should also give a useful description. Perhaps we could put in the date that this rating curve was defined, specified, any kind of useful description for to remind yourself or later economists where this rating curve came from and what it represents. So we have our table on the left-hand side. We have our plot on the right-hand side. We need to define the coordinates. We will have an x value, which is the flow, and then we're going to have the y value, which is a distribution of stages. All right. The very first thing is to insert a row above. We want a coordinate for zero outflow. For the zero outflow, we want the invert stage. Now, the invert stage might be 0.2. All right, and we're going to use the normal distribution for all of our coordinates with a linear interpolator. So the standard deviation of the invert stage might be 0.2. Going from there, we might have 0.5, 0.751, 1.5, and 1.75. All right, and we don't need this last coordinate. So there you have a rating curve. And you can see the plot on the right-hand side. We have nice positive, strictly monotonic bounds about our mean rating curve. So this is a valid relationship. Finally, we're going to click Save so that we save this rating curve with the useful name and then close. That's it, folks. Thanks for watching, and stay tuned to the next video.